This is lesson 8.1, Right Triangle Trigonometry. For this lesson, I won't be doing every single problem, but any problem that I don't do will still be available on the notes. All right, to start off, remember what we've learned about Pythagorean Theorem in the past. Remember that it's only used for right triangles, and we use it to find missing sides. So we've learned before that if you have a right triangle, you have the legs, and then you have the hypotenuse. And we've learned before that if you take a leg squared plus leg squared, it equals hypotenuse squared. So just recall that. So a squared plus b squared equals c squared. When you use the Pythagorean theorem, the only angle that you have to know is the right angle. We don't care or need to know really what this angle is and what this angle is. So they might both be 45, they might be 20 and 70. We just know that they're all going to add up to 180, and that those two that I marked in red will add up to be 90 because that's all that's left for that triangle. But what if we knew another angle, but we only knew one side of the triangle? So what if we have a different situation? So what if we don't have two legs or two of the sides of the triangle? What if we have a right angle and I say this is 20 degrees and then I say this one is 6? You can't use the Pythagorean theorem anymore because you don't have enough information for that. So what our right triangle trigonometry does is it allows us another way to find missing parts of a triangle. So depending on what you're given, you can go about it a different way. So trigonometry is literally the study and measurement of geometry with right triangles, so triangle geometry basically. After you do right triangle trigonometry, you can expand study to other types of triangles, so non-right triangles as well, but we're not going to be doing that in this class. So we're going to learn, first of all, 3 trig ratios. So remember, a ratio is a comparison, and the most familiar ratio that you've learned before is slope, where it's rise over run. And so it's a comparison of two numbers or two measurements or two lengths. And so we're going to learn these 3. So the first one is called sine, and it's pronounced the same way that you say the word sine, like that, but it's spelled S-I-N-E, and it's abbreviated with S-I-N. Please do not say sin. That is not how you say it. Okay, the next ratio is cosine, and the next one is tangent. Now, even though it's related to a tangent line, we've learned about like a tangent line of a circle before. So tangent, when we're talking about triangles, it is related to that, but it's not what we're going to be doing right here. So talking about sine, it is the ratio of the side opposite to the hypotenuse. So again, if we think about our right triangle, and these ratios are only work if you have a right triangle for this type of situation. And so if I know, let's say that the hypotenuse is 8 and that this is 20 degrees, and then I can say this angle, the side opposite, is that side right there. So this is my side opposite, so I'll just put A right there. So if I said the sine of angle A, so the sine of 20 degrees is equal to opposite side over hypotenuse, I can actually solve that equation. So I can solve it by saying multiply by 8 and multiply by 8. Now this is where you're going to get your calculator. One thing to make sure of is you need to make sure your calculator is in degree mode. If it is not in degree mode, you will get the wrong answer. So you need to go to mode and you're going to choose degrees. Okay, I've inserted a little picture here of what the calculator looks like. So you go to mode, and you're going to go down to where it says radian and degrees, and you're going to highlight degrees. And then just hit enter to make sure that that's chosen, then you can quit. So before you do any of this calculation, you have to make sure you're in degree mode. If you are not in degree mode, you will get the wrong answer, and that's on you. So once you make sure you're in degrees, then you're going to type in 8 and then find the button that says sine. Okay, it's just right up above, like 2 buttons above the 7, and then 20, and then you hit equals. And so when you do that, you're going to get an actual number. Okay, so that's how we would find that, so we could find out what that actually is. For that example, it'd be 2.7 or so. There's going to be a lot of rounding in here because when you do these ratios, they don't often come out nice and neat, so they're going to usually be some interesting fractions. But anyway, that's how you would use a trig ratio. So just going on to the other ratios that we see, cosine is the side adjacent over hypotenuse. So again, if we're looking at a right triangle, so you have your right angle, and of course the right angle is across from the hypotenuse. That's always true. And then depending on which other angle you're given, so if I say here's this angle, then this would be the side adjacent and this would be the side opposite. But if I give you the other angle, so if I say, no, this is my angle, then this is my side adjacent and that's my side opposite. So you have to make sure you understand that the adjacent side is going to be relative to which angle you're talking about. Tangent is the ratio of opposite over adjacent. So in this picture that I have down here on the screen, opposite, if this is my angle, the purple angle, if that's my angle, then the opposite side is this one, and my adjacent side is right next to it. So adjacent is the one right next to the angle, and opposite is across from the angle. You're never going to have 90 degrees be the angle that you're talking about because that's across from the hypotenuse, and that doesn't give us any new information. Okay, continuing on, we also have reciprocals of our ratios. And remember, a reciprocal, like if you have 3/5, the reciprocal is 5/3. And if you multiply a number times its reciprocal, you get the multiplicative identity, which is 1. So the cosecant of angle A, what that is if you look, we've got hypotenuse over opposite, and if you look back at your other ratios, that's the reciprocal of sine. So cosecant is basically 1 over sine A. So it's a reciprocal. So instead of being opposite over hypotenuse, it's the other way around. Okay, for secant, it is abbreviated SEC, and it's hypotenuse over adjacent. So that's the inverse of cosine. And then cotangent, that one's easy to remember. It's the inverse of tangent. So it's the inverse of tangent. So a couple of things about that. One way that I remember it is I remember that the cos do not go together. And so like cosine and cosecant, they do not go together. Okay, so that's one way to remember it. So, and then you do need to remember, if you can remember these three, the sine, cosine, and tangent, then it's not hard to remember the other three as long as you know which one goes with which. So I don't particularly like this one, but this is how the most common way to remember it. And so SOHCAHTOA, and that doesn't make any sense, and it's not even words or anything like that. It doesn't stand, I mean, you can't put it with anything. But SOHCAHTOA is a very popular way to remember this, and so it's spelled like that. So is SOH, so that's sine is opposite over hypotenuse, ca is cosine is adjacent over hypotenuse, and toa is tangent is opposite over adjacent. The one that I like is I like to think that each of these letters stand for something in a little sentence. So I say, some old horse came a-hoppin' through our alley. And so that's how I remember that. I like it better than SOHCAHTOA. It doesn't sound as dumb, but whatever you want to use. Okay, so we can use both the ratios and the reciprocals to solve triangles, and that when we solve triangles, it means find whatever's missing. So we're going to start with this example right here, and so we see that we have a right triangle. We are given the 3 sides, and so what we're going to do first is we're just going to practice writing the 6 trig ratios. So it says in the problem, it says the first is sine of x. So we need to remember that sine is opposite over hypotenuse, and since we're talking about angle x, we're talking about from that angle. So that's very important that you know which angle you're working from. So if I'm looking at starting at angle x, opposite is 12. So it's going to be 12 over, and then the hypotenuse is 13. So that's my ratio. Don't put it into a decimal unless you need to or unless you're told to. Okay, and then if we're going to find the cosecant, which is the inverse of that, all you have to do is write the reciprocal. So 13 over 12. All right, the next one, it says the cosine of x. And so cosine, remember, is adjacent over hypotenuse. And so if I'm starting from x, adjacent is the 5 over the hypotenuse. So the secant, which is the inverse, is going to be 13 over 5. Okay, tangent of x, and so tangent is opposite over adjacent. So from x, opposite is 12, and adjacent is 5. And then the cotangent is going to be 5 over 12. Now, one thing that will be a little hint for you, and this can be like a way to check, your sine and cosine will never have an absolute value greater than 1. So it's always going to be between 0 and 1. Okay, it can be 0, it can be 1, but it's not, your sine and cosine will never be bigger. You'll notice that all of the other ratios, they can be bigger than 1, but that's one thing about sine and cosine is they'll never be bigger than 1. We'll figure out why later, but I'm just telling you that for now so you can remember. Okay, a couple things to remember. If you just say cosine without saying cosine of x or of some angle, so we could say cosine x or cosine theta is a really popular one, that it doesn't mean anything. So if you don't put an angle with your cosine or your sine or your sine, then it doesn't mean anything. So you need to make sure that when you're writing like cosine, you have to say cosine of something. You can't just say cosine equals. And so make sure that you do that. Okay, so now we're going to actually solve some triangles. So it says find the value of each trigonometric ratio. So the cosine of angle C. So angle C is what we're starting out. Cosine is adjacent over hypotenuse. So the cosine of C is going to be adjacent, not the hypotenuse side. The hypotenuse is not the adjacent. It's going to be 30 over the hypotenuse, which is 50. You do need to reduce your fraction, so that's 3/5. You do not need to write it as a decimal. There's no reason to do that, and you're not told to do it. So you would just write cosine C is equal to 3/5, and that's your answer. Now, as we go throughout this whole unit, we're going to learn a lot more about like what does that mean and why would that number be helpful at all? Who cares what cosine is? So we'll find out like what it all means, but we're starting with some basics here. So looking at 3 cosine C. So this is my angle C, and so cosine again, it's adjacent over hypotenuse. Remember that the hypotenuse is not going to be your adjacent side. So 16 over 20, and you'll reduce that fraction. So we're just going to say cosine C equals 4/5. Okay, going on to the other ones, you're going to be doing the same type of thing, and so I'll just do one of these, and you can look at the other one on the notes if you want. So this one says sine Z. So remember, sine is opposite over hypotenuse, and that might help if you just write down that ratio. And then mark angle Z because that's the one we're going from. You want to make sure you know that this side is the hypotenuse, so that's not going to be the opposite side at all. The opposite side is going to be the one right across from it, so it's going to be 35 over 37. And we can't reduce that at all, so that's going to be what sine Z is. So going on to number 6, which is the last one I'll do in this video, cosine X. And so again, mark X. Cosine is adjacent over hypotenuse. And so which one is my hypotenuse? 41 is my hypotenuse, so I'm going to have that in the hypotenuse place. And adjacent is going to be the one next to it, and so that's going to be the 9. So 9 over 41. That does not reduce, so the answer is cosine X equals 9 over 41. So that should be what you have on your paper. Okay, we'll continue the rest of the lesson in the next video.